So here we are to discuss the next form of classification, which is called as scalar matrix. So we've already seen basically what a row matrix, a column matrix, a square matrix and a diagonal matrix is. Let's move into understanding what a scalar matrix is now. So I would like to write the definition here, and now since you've already seen a definition before, I would like you to think on similar lines and try to understand what a scalar matrix is before I disclose it myself. So the definition goes simple. If Aij is an element in a scalar matrix, if Aij is an element in the scalar matrix, then Aij will be equal to 0 if your I is not equal to j, and some m if your I is equal to j. With this, I guess you can make a sense of what it means. So, for example, let the order of the matrix be 4 by 4, something like this, right? So once again, if I am talking about Ij here, I would like you to notice that a scalar matrix also has to be sort of a square matrix. Only then this diagonal makes some sense, right? So basically, why did I use the word diagonal here? Because you'll see. Let's first actually draw a 4 by 4 matrix here and try to understand. So this will be your A12 element. Your I will not be equal to j, so you'll A11 element, which should be equal to some m, right? Then here this will be your A12 element, which will be 0, 13 will be 0, 14 element will be 0, because for all these three your I is not equal to j. Then you'll start with a 0 again, you'll put an m, you'll put 2 more zeros, you'll start with a 0, you'll put another 0, m, 0, and 0, 0, 0, m. How did I fill this now? This is your A44, right? A44. This particular element is your A44. So your I is equal to j. So first of all, if it is a 4 by 4 matrix, then your I can start from 1 to 4, and j also can go from 1 to 4, right? Because it's a 4 by 4 matrix. So it will be m only for A11, A22, A33, A44, right? Only then your i's will be equal to j's. For those 4, it is m. For everything else, all the other elements are 0, right? That is what you mean by a scalar matrix. So now the question is, how can I actually define this in words? I can say that a diagonal matrix whose all leading diagonal are equal is called a scalar matrix. So I can obviously define it in this form. Now, what does this statement mean? This also is a diagonal matrix. Why is it a diagonal matrix? Because this condition is being obeyed. This was the sole condition for any matrix to be a diagonal matrix, right? So the first thing was a diagonal matrix had to be a square matrix, right? So if I say if I use this definition, a diagonal matrix whose all leading elements are equal and it's called a scalar. Such an matrix is called a scalar matrix. It's very, very clear that a scalar matrix, first of all, before anything else, is also a diagonal matrix, right? A scalar matrix is also a diagonal matrix, and if a diagonal matrix had to be a square matrix, a scalar matrix also has to be a square matrix. So this is what I wanted to tell, that just like a diagonal matrix, a scalar matrix also has to be a square matrix. Now, for a square matrix, if this definition was satisfied, just if this definition is satisfied, I can say that it is a diagonal matrix. So now here for this definition is being satisfied. All the elements other than the principal diagonal, this is what your principal diagonal is. It goes through like this. So other than this, everything else is 0. So fine, it is a diagonal matrix. Now the additional condition is this: all the elements have to be equal. Now this didn't have diagonal elements didn't have this restriction, right? So for a diagonal elements, this 1, 2, 3 and 0, 0, 0, 0, 0, 0. This can be a diagonal matrix because all elements other than principal diagonal are 0 and principal diagonal elements are non-zero. In fact, principal diagonal elements being 0 or non-zero is not even the criteria. The criteria is elements other than the principal diagonal have to be 0, and that's being ensured here. But can I call this a scalar matrix? No, because I can't, because the elements in the principal diagonal are not equal. They have to be equal to some m. So that is the additional restriction which is put on a diagonal matrix. An additional condition of their principal diagonals being equal, principal diagonal elements being equal, is put on a diagonal matrix, and then a diagonal matrix is converted into a scalar matrix, right? I want you to have this trace. So this is very, very simple. So can I call this as a scalar matrix? Yeah, because the diagonal element is this, sorry, the principal diagonal is this, principal diagonal elements are equal and other elements are 0.